this week we're going to talk a little bit more or focus on inspection. Just for a safety item, just something to somebody's came up with this acronym for track. Think about the job. What are you going to plan on? What are you going to be doing? Recognize the hazards. Kind of take a good assessment of what potential risks you have with the work that you're going to work on. And what can you do to control them hazards? What kind of things can you prevent to minimize the potential for getting yourself caught in something that where you don't want to be? I think one of the big things about safety is making sure that you always got a way to get out. And make sure that you don't get yourself pinched in between things. That seems to be one of them areas where we run greatest risk. And always focus. I think that I always look at it, even a hard hat. Very rarely when you're on the railroad are you going to run into, you actually have something fall on your head or bump into something. There are cases that you do that, but I always see the hard hat as just one of them things. Is put that on. That that is just to make sure. Just a reminder. Safety is important, and it's one of the things that that I've learned over the years is that it's that right frame of mind is the real main item in safety. What we're going to be looking at, is just a continued kind of get everybody familiar more with the railroad environment. Some of the things that occur that a lot of times we're not aware of when we, especially in our design. Even if we get into the detailed design, we're not really worrying a lot about, or we don't get necessarily involved in inspection. That's done mostly by the railroad. Even when the consultant's doing it, usually we're getting involved with somebody that's got a lot more experience on the railroad, that's been on the railroad. But I guess why is this important to do our design effort? And my feeling is that the more we understand what the railroad is doing and what it's about, the better idea that we have is to try to minimize potential problems, making sure that maintenance is something that we're considering, making sure that we have access. So the more we understand what that environment is, the better off we are. We were going to take a look at, some of what are the FRA safety standards, and get into that, delve into them in a little detail. A lot of times, I hear, and we've talked about it a little bit in the past already, is that we're going to design to the FRA standard. What is the FRA, or maybe even more to the point, is what does the FRA require you to do? And one of the things that I just want to hammer it over everybody's head is that the FRA is safety standards. There are minimum safety standards. So if you fall below that, we'll talk about what you have to do when you do that. But they're not, they're never design criteria. They should never be used as design criteria. Sometimes when you are doing maintenance or track construction and you're still going to be, keeping the track in service, that's the only time in my career that I've really used them, in a proactive way of actually something that I'm building. I just want to make sure what is the, if I'm going to, want to increase the track to 30 miles an hour, what do I have to do to make it sure that it's passable for 30 miles an hour? That's a temporary condition. That's not what you're designing to, but that's what you're building it to for a temporary condition. And we'll talk a little bit more about that. And then what is the, trying to understand, what is that relationship with our design? How is that going to be practical to us? We're going to take a look, and concentrate, on the inspection. Track inspection, got the importance of track inspection, some of the methods that we use, the application, as I just mentioned about the track safety standard, some of this, talking a little bit about the specialized inspection vehicles, and, some of the maintenance practice, preventive maintenance, typical activities that the maintenance crews are doing. The more we understand that, we have a little bit better idea of why access, is important. Production activities, what kind of, track work equipment is going to be used, and how do we integrate that into into our plan. The importance of the track inspection. One, the FRA. It's a safety. The safety. That's the overriding focus. The FRA is the safety compliance, making sure that the railroads are safe. So keeping, we're worrying about the public, the employee safety, making sure that the railroad environment is something that everybody walks away from at night. You hear a lot on the news about cars getting away and then causing major problems, and those are major derailment, hazardous material spills. But the whole purpose here is trying to make sure that whatever we're doing, the condition of the track is such that those situations can be kept to a minimum. And the importance, the first and the last line of defense against track-related derailments. There's a lot of things that can cause derailments, but one of the major ones is going to be track-related. I worked on a bankrupt railroad, and consequently, there's a lot of things wrong with the railroad. The equipment was bad. The rail cars, were marginal in a lot of cases, but it was really the track that had, the majority of the causes, of our derailments. We're going to take a look at, the difference between, high rail inspection, walking inspection, and train inspection, and why, what are the important elements of those. A high rail, that's a normal thing. You're going to normally see, you often will see that, at a crossing is generally where you're going to see it, because when the maintenance guy, or, a lot of times it's going to be a track inspector, a roadmaster, a foreman will get on the rail at a crossing and go down the rail on a high rail. This is one of the key elements there. Is it allows you to get over your territory faster than you get it over once. And back in the day, you had to do it on a motor car. It was easy to get the motor car on and off the track, and you have a lot of these motor cars set off, but you'd go in one direction and you'd have to come back on the motor car, because the only way you could get back was on the rail. High rail allows you the ability to get on the highway and drive back to where you started that evening or that morning. It's one of the most common methods utilized, for our schedule and normal inspections. The FRA requires that certain classes of track, and we'll talk about what those are in a minute, that, certain class of track, you'll have to inspect it, up to 3 times a week, and at certain intervals, and never, 3 times a week, and you have to, not have more than 3 days in between one. You can't do them all 3 in one day, for instance. A lot of rules on when them inspections have to be made. The railroad is going to have regular scheduled inspections. The railroad I worked on, and most of the railroads have a spring and a fall bridge inspection. They'll inspect all the bridges and all the culverts every spring. That's when we did it. The brush is usually down. The water's flowing, so you can kind of see what the situation is. It was something that was kind of the annual thing. That was one of the things that we participated in as project engineers or field engineers. You're going to have, try to look at the track, for, visual detection. One of the things you're going over the track at a fairly good clip, so you're going to take a look at what are some of them telltale signs, and we'll talk a few about them, and you can kind of see when you're going across the railroad at 30 miles an hour, there's only certain things that you can see. You can't, you're not going to be able to check the gauge, for instance. But you're going to have telltale signs of something just doesn't look right there. You're going to stop, take a few measurements, and make sure you know what you're doing. You're going to have a little feel for the sound, but we'll talk a little bit about that. With rubber tires, and on the high rail, The real problems of the railroad are not quite, that feel and the sound of the track was a lot better. I heard that our railroad even delayed going to high rails until they really started cutting manpower, is because when you're in a high rail, you didn't have that real feel for what the issues were. But then when you want to try to get down into the nitty-gritty of the track inspection, making sure that the track was at gauge. You see a guy here checking the gauge, checking the cross level. You're going to do some, quantify those defects. You're going to try to have some actual measurements. A lot of times what the railroad guys will do is, if they find things that they want to get picked, they'll identify it by, by a mile post, approximate location. Sometimes they'll go tie a piece of ribbon. A lot of times they would have, on our railroad, bankrupt railroad, they tied them on a tree or a brush on the side, so they didn't want to bring attention to the FRA inspector. That was just one of them little things that you did. But anyway, the walking inspection, you're going to get down into the actual measurements of track components. You can check the gauge of the gauge. You can check the wheel or the rail profile to see if it's within the tolerances that you want to look at. A lot of times the railroad, wanted to make a walking inspection of all their turnouts, once a year, once every 3 months. There's certain things that you had to do by law, the FRA requirements, but there's a lot of things that were added to the railroad just to be safe. Train inspection. A lot of times what roadmasters will do is try to ride a locomotive over their territory, maybe once a month. And what they're doing is, how does it really ride? And you get that feel. This is where you kind of feel that how is it riding? Particularly, I knew one of the roadmasters is on our railroad, but the Metro operated on that, and he would ride in the locomotives, a little more frequently, because the majority of the traffic on his railroad was Metro trains, and you had that passenger comfort. You get that feeling for, how is the railroad responding on their loads, because it's going to be a little different. There's no regular requirement to do this, but generally the railroad will have a policy of what they want to expect from the roadmasters, but it gives them a good indication of, where them bad spots in the track. And one of the things that I know is a lot of times the track might be better, when if you slow down, you get a pretty smooth ride. On our railroad, when you got up to 45 or 60 miles an hour, the ride was actually fairly rough. The track was way better, but it didn't ride real well, and you had a good feel, of how close it was getting to that situation where you're going to have to do a little more maintenance, or you're going to slow the track down. Just a couple of things, types of the track inspection, the normal one, the schedule, that's a routine ones, the ones that are required by the FRA, the ones that are required by the, the company expects to, they may expect once a year to take a look at all your switches in the yard, turnouts in the yard, maybe actually do a defective tie count in your yards to make sure you knew what tracks are going to need, repair. To, one of the things that they're used to, those inspections are used for, is developing what the maintenance program is going to be right at that minute, right at that time, if it's required, or possibly special, identifying what next year's program will be. You'll have special inspections. I mentioned in spring and fall bridge inspection. We had a general roadmaster in charge of rail. He would come around and check out some of the curves, check to see how much rail wear was occurring in the curves, and trying to identify for the future how many more years will it be before he needs to relay the rail? After major storms, you're going to want to, somebody is going to want to inspect the track. We had one situation, just as an example, that because of the rain and there was some areas were susceptible to flooding, and the division engineer required that the roadmaster have somebody inspect the track through this area, ahead of every single train that they ran. Well, in this one situation, they had two trains that were right back to back, and so what the inspector did was not, I'd have to drive through this 10-mile stretch, and then I'd have to drive back, and then we'd delay that train. So he'd inspect it once and have the two trains follow each other through this territory. Well, because of the way the situation was, the track actually washed out in between the first train and the second train, and the track was ended up being out of service for better part of 3 weeks because they derailed. And, of course, if you're going to derail, it's not just going to be a couple of lumber cars that was hazardous material in a creek and caused all kinds of situations. So when you have special conditions, you need a special inspection. Then we'll talk a little bit, identify a few things here, track geometry cars and equipment that and trucks that will actually inspect the rails, looking for defects. We're going to talk a little bit about these. Monthly inspection. That's going to be some of the, the special. That's where you're going to look at the turnouts. All the mainline turnouts need to be, do a walking inspection, possibly monthly, where the track needed to have, 3 or 4 times a week, depending on the class of track. The FRA and in Canada, Transport Canada, will identify what the minimum inspection frequencies are. And then it was important to report what your inspection revealed and then what was done about it. And we'll talk about what are some of the actions that when you find the defect of what you can do. One of the things that I think would be interesting to look at is, again, it's not a design standard, but to get one of these track safety, a lot of times you can get them on online nowadays. So I think that's the best way. Subparts A through F here. The example in this photo is a general track that's going to be up to freight up to 80 miles an hour. Part G, I believe, is the higher speed. But the important thing is to kind of look in there. What are some of those criteria? We're going to take a look at some of them and what does this actually say and how does that apply? So we're going to be, what are the defects? I mentioned, a class of track. This track is going to be good for, 10 miles an hour. I think we've got coming up here, identify, it's generally going to be, the class of track is going to be fine. How fast can you go on that piece of track? And we'll instead of just guessing, we'll get that in a couple slides here. We're going to try. Some of the things are not specific. Sometimes it's more of a subjective. Sometimes it's actually how many defects per. It gives some real criteria. Other ones are a little bit more. And what we have over on the side there, repair, restrict, or remove. So if you find defects, there's some defects that the track inspector can repair right there on the spot. Back in the day when you had more jointed rail than you do now, if you didn't have enough, if the bolts had come out of a rail joint, that the track inspector could put in if he found some bolts missing, you could put the bolts back in and not have to slow order the track. You can restrict it by dropping the speed down to one of the classes that that is acceptable. Just as an example, to run 10 miles an hour, you needed one bolt in each end of the rail. Well, if you had two bolts, if one of the bolts was missing and you had 40-mile-an-hour track, and you only ended up having one bolt and you didn't have any bolts to fix it, or for whatever reason, you could fix that defect by restricting the speed to 10 miles an hour or whatever class that it was acceptable for. And they got to be so bad, your remedial action would be you just have to take it out of service, until it did get repaired. There's certain I came across when I was laying out tracks, when I was on the railroad, we released we did all our work during the, generally in the morning of this one year, and then I did a lot of track layout stuff in the afternoon when all the gangs had left. But I came across a broken rail in the area that and we had released a whole bunch of trains, because we had the track shut down for the whole, for about 8 hours, from about 6 o'clock in the morning to 1 o'clock, and I came across this broken rail. Well, what are we going to do? So it was in such a situation where we could walk the trains over. We want to keep the trains moving the best that we could. So that one of the ways of doing that is if somebody was inspecting it and watching the trains, we could walk it happened to be a broken rail that was basically tight together, both the rails, because the rail, was hot. The rail had come together, and the rail was broken right over a tie. So there was no problem of it getting displaced. So you just did a walking. You just walked the trains over. So we walked the trains over, and then the section crew came out there, and after the first 6 trains that we had that were kind of backed up, after they had left, the section crew came out and repaired the track. And here's the class of tracks done by speed. Class 1, 10 miles an hour. Class 2, 25, 30 per passenger. Class 3, 4, and 5. As a general rule, I believe that anything that's above 79 miles an hour needs to have cab signals, which are signals that the engineer can actually read in the cab of the locomotive, so you don't have to depend on his eyesight or visibility of the signals on the track. So there's some other criteria, but these are the normal classes that in freight service. In passenger trains, like I say, there's higher classes when you start going into that higher speed. Some of the other things where say it's more subjective. The drainage requirements here. The top picture. You got a problem there. When you have a situation like this, you got to look and see, is a ditch plugged up? Is a culvert plugged up? What is the real cause of this? And look to fix that. But it's not like how many good ties do you have per rail length or whatever. You're going to be looking at a little more subjective type thing. Down on the bottom, if you have a lot of one of the things that the railroads do is a lot of weed spraying. One of the reasons for that is so the brush don't build up. There's a pile trestle bridge with the grass right up next to the track. Usually they'll cut that out of there. So if the locomotive is, the locomotives are getting a lot better as far as out of the smokestacks. Occasionally they'll get ash. It might start a fire. The sparks from all kinds of different things along the railroad. You certainly want to protect not only from starting a fire, but also, protecting your bridge. So you don't want to remove. So that's one of them other type things. You look at the road bed. Take a look at, more specific things on track geometry. On gauge, here's another, just a perfect example of, when we say these aren't design criteria. Gauge on a railroad, is 4 foot 8.5 inches. So one of the things is narrow gauge. That's usually the worst situation, but it's the same for all the class of the track. You can do a 1/2 inch of tight gauge, but on the other one you could be 4 foot 8.5. So we got a class 1 track can be 1.5 inches wide, and you have to slow the track down to 10 miles an hour for class 1. Class 2 and 3, I think it's 25 and maybe 40, and there you only have 1 1/4. You could get to be 1 1/4 inches wide. And at class 4 and 5 track, you could be 1 inch wide. So you're trying to identify what situation. One of the things they picked this picture, and when I was saying that you take a look when you're going down at 30 miles an hour or 20 miles an hour on the high rail, you're going to be looking for certain things, and you can see this kink in the rail here. You've got a little bit over here, but it looks like it's worse in here. Generally, them two rails should be, real parallel and nice and smooth, especially inside of a turnout. Well, there's probably some, I think it's a pretty clear thing is that something else is especially wrong in there. So when you have time, you're going to go down there and check that. Most likely, that's going to be a situation where you're going to have wide gauge, and then you're going to measure and see, does it fall into one of these categories, and what you're going to have to do to fix it. Alignment. Generally, with a on tangent track, if it's if the track is wiggly, you have a 62-foot cord. You can be up to 5 inches. One of the and that's pretty bad. One of the things that on a 62-foot cord at the midpoint of that, just something to remember is if you ever don't know that want to check the degree of a curve, is the degree of a curve with a 62-foot cord at the midpoint, so you're going to measure at 31 feet, the distance between the string and the gauge side of the rail. If it is 5 inches, that's actually a 5-degree curve. It's 3 inches, it's a 3-degree curve. So if you do check that, that's just one of them ways to check and see what, and right nowadays, for the most part, nobody's checking things with strings. That's something that you might have to do on a special case, maybe a branch line or something. Most of the time, that's being done with some type of track geometry type thing. We're going to take a look at some of the surface issues. You're coming off an open deck bridge going into a ballast deck bridge, and you see the runoff. The FRA safety standards will say that runoff in a 62-foot cord, the biggest difference. So you'd hold 62-foot piece of string from somewhere out here and up to the top of this thing, and that dip can only be at at some set thing for the given class of track. That was one of them areas where in one track rehabilitation project that we were working on, we were raising a lot of our bridges. Well, we'd raised the bridge, and our railroad, there was a lot of other things going on with it. We were fixing it that first night. A lot of times we'd keep the track, at 10 miles an hour or 30 miles an hour, something slower speed. And then there's a certain FRA minimum runoff that you'd have to do in the slope. So that was one of them times where I actually used the FRA safety standards to actually build something, but it was a temporary thing. We'd do that to just get whatever, because of time. Then we'd let the trains, the trains run overnight, and then we'd fix it in the morning. There's another, the track profile, same thing. How bad of a bump, if the train's going too fast, they're going to start bouncing out of there. If they're bouncing, hit that thing too hard, it's a situation where they can come off the rail. One of the other things that you want to do, you're going to check cross level. So this guy's checking the cross level, and this is a notorious place of where you have problems. It's an insulated joint, and at a signal, it's normal. But you can see right now that the rail is sitting up. It almost looks like it's an inch higher than the tie plate. So even though the cross level might be halfway good, you have to take into account that when a train is on there, that one's going to stay where it's at, and this side is going to, depress another inch. So chances are you've got a significant problem there. You're probably going to have to slow the track. Another, when you have these situations, you're going to see all the mud pumping up through the track. It's another one of them telltale signs that something's going on wrong with the track. The ballast shoulder might be, even though you got nice ballast out here, it might not, there might be, it's fouled. There might be a lot of fines in here, so the water doesn't drain out of the ballast as it starts. When it does rain, it pumps up. If the railroad is pumping, up to an inch, I've heard that, for every inch that the track pumps in a situation like this, can draw water, with capillary action from 10 feet down. So even though it doesn't look like you're up on top of a fill, you can get this situation because they're sucking the water out of the ballast or out of the subgrade. Difference in cross level. In jointed track, you're going to have to watch that. Get a low joint on this side, higher on this side. Them are things that you're going to watch. This is alleviated by welded rails, so you don't have them situations. Because that worst case scenario is actually if you get it too bad, the rail car, go too fast on it, it starts going back and forth and rocking, and sometimes they have actually rocked off on the track. It pulls the rail up, or the wheels up off the rail, and once the wheels get up on top of the rail, if you run off and then one of the wheels will fall on the outside, and you obviously come off the rail. Some of the track structures is going to be wear on a switch point, or on a point of the frog, how much damage is done there. A switch point, how close you want that to fit. One of the problems is if it don't fit real tight when the train is coming, and the wheel has a tendency, if the wheel isn't, the flange of the wheel is tight, real thin, it might actually split the point and get in between there, pushes it out, and then the track, you get the one wheel going down one track and the other one going down the other one. Obviously not a good thing. Cross ties, and here's another one of those things. They're saying the number of non-defective ties required per 39-foot rail. You can have 5 in tangent track up to 2 degrees. There's about 24. On a main line, there's probably about 24 ties per 39 feet. So here's a case where you can go 10 miles an hour if you only have 5 good ties in that area. You're never going to design it like that. That means, when you have those defective, what that means is the other ties are still there, but they're going to be defective. They might be split. They might be plate cut. Some of the other defective things. When you're going, every other tie is generally going to need to be good. One of the other criteria for cross ties is that you have at least one good tie underneath the joint. On the railroad that I worked on, that was one of the major criteria or problems that we had. Was it's usually one of them first things that fail. We could get the on our 25 or 30 miles an hour track, we could get the eight good ties in a rail length. It's only a third of the ties are still good, so 2/3 are bad. But we failed because you needed one of them 8. You had to be in any of the joint, underneath the joints, you had to have at least one good tie under every joint. And if you didn't have 2, then you were down to 10 miles an hour. Mentioned some of the specialty equipment. Here's a Sperry Rail Service vehicle. They will actually do inspection of the rail, identify problems inside the rail. Those a lot of them things that you can't see. There's defects inside the rail. At some point, the rail will actually break. Sometimes one of the problems you'll have back in the jointed track day or in the yard is that in bolt holes, through the wear and tear and the pumping action at the joints, you might get a bolt hole break. It starts to crack out of one of the bolt holes, and then eventually that piece of rail will actually pop out of there. But when that crack starts to form, the rail detectors are used to try to identify those before they become a problem, before they break. Usually, if they do break underneath the train, it's generally going to be a derailment, and you obviously don't want to do that. One of the ways to fix these defects is, some defects you can fix by putting a bar on there, and temporarily, and then you replace the rail or that section of rail at a later date. These are some of those internal defects. We don't want to get into too much detail. It generally doesn't get too involved with what we're doing, but it's something to understand. I think there's a lot of things that go on in the railroad that until you actually been out there, you don't realize, and this is one of them of what actually happens with the rail and some of the problems that they can have. Generally, the engine burns, is an example where they spin the wheels, and then what happens there is a lot of times there'll be a fissure in one of the problems, that actually starts a fine crack through the rail, and eventually it'll actually break the rail. And certain different things. Some of them are, I'm not quite sure what this, well, that's just a defective weld. So you can see that it's not, it didn't take, so it's not going to be as strong as it needs to be. Appliances, you're going to take a look at, there's certain tolerances to make sure that they're adequate. A lot of times the railroad will have, defective tie counts, rail wear, rail grinding requirements to try to improve the shape of the rail head. They'll identify, besides, when you might want to replace the rail because it's getting curve worn in some sharp curve. A lot of times you'll get some minor imperfections in the surface of the railroad. There's some rail corrugation, which actually is like, almost like a little bumping of that washboard effect that you often see on a gravel road. Unless you see it on the railroad, it's one of them things you have a hard time believing that it actually occurs. But it's just like a bumpy gravel road, and the locomotive obviously or the rail cars don't travel real well on that. But one of the ways to fix that and keep that under control is rail grinding. So that's one of the things setting up that maintenance program is something that you're going to do with the track inspection plan. You're going to look at crossings in another area. Known problem areas, the areas that, we've always had, the subgrade might not be very good here. So we're going to watch that surface of the track. A lot of times when it gets a little bit out of line, usually another one of those indications where, there's some kind of pumping action going on. Maybe the track is getting out of line because, even without, in welded rail, it'll start, one side will start going down, so there's more forces on that rail. It gets out of line. So whenever the line isn't real good, that's an indication where something might be wrong. You're going to want to go take a look and see what I can do with it. That emergency inspection that we call, you're trying to find these things. That's why you make them inspections, where you got it controlled, and take a look at if you're not in that situation I mentioned earlier, you're on there and all of a sudden your train ends up in a ditch like that. It's a lot better to find this thing on a high rail with a track inspector. You're going to stop running trains for a while, but at least you're not having to pick up rail cars. We mentioned the inspection records. There's forms that you need to fill out. You need to keep, they're on file for a year. When I was on the railroad, that was one of my jobs, is to keep sure that all of our section men were maintaining those records. The FRA inspector, not only would come out and check the track, but he'd come into the division office to make sure that we were keeping our records, making sure that whatever, like in these examples, tell them where the track or what was happening, put a slow order on. That's how insufficient ballast in the cribs. What did they do? They reduced, put a temporary slow order at 25 miles an hour. So that fixed it. He basically, brought that track down. So even though he didn't do anything, that was what, referred to as fixing. There they had a 2-inch pull apart. That one, that was a major concern. So we had to call the section crew out there, and they fixed it right on the spot. That would have been something that they'd have to take the track out of service. But you need to sign it. You're making sure that everybody is being honest and accurate. It was a schedule maintenance or a schedule inspection. How it was done, how was it identified. Different detector cars. So we've seen that one that was more of a high rail vehicle. This one's more of a train, identifying, like a locomotive type vehicle. The railroads generally, and most of the railroads are going to be inspecting most of their lines at least, once or twice a year, making, trying to identify any of those rail defects ahead of time. Track maintenance, normalized maintenance, performed by small section crews. It's a day-to-day maintenance. The section guys just generally make emergency repairs, and then the program maintenance. Capital projects. Most of the railroads, capital money is, in the track department is going to be spent on, replacing ties, replacing rails, replacing grade crossings, and replacing bridges. Some of the type of work that you'll see, electrical crew on a catenary, working up on the catenary. It's a rail car. Some of the types of normalized maintenance, putting up, replacing rail. Cutting a new piece of rail. So you can see, or you can get there by rail, but if you are doing maintenance out there and that you're sitting on the track with your truck, you can't run trains, you take it out of service. This guy's going to have to run in someplace and go to the next siding or somewhere, or a crossing to get off, and then let the trains go by or come back. So a lot of times what the railroads are going to want to do is have access to them things, so they can get down there, they can do some minor, get it prepped, ready to make the repair. So after a train goes by, They don't have that time of, they have to go into the clear, they're right there, and then as soon as the train goes by, they take the track out of service, make the repairs, and go about their way a day. So that's one of the things when we hear and request of track, access roads, a lot of times on major leads and things in a yard, the railroad will generally want some kind of an access road. I've seen a lot of the railroads will actually go in. And I've seen some cases where they've built a road that 6,000 feet long to get down to a signal or to get to a turnout that they need to maintain because of the time that it takes to run something in the clear to make the repairs. Just a couple other, the weather challenges, plowing snow, flooding, a major problem on the railroad, washouts. I think it's supposed to. Not going to take too long. So here are some of the things we're going to be looking at. Bridge scour, a situation. I was on a bridge. It's too. The track is about 150 feet above the creek. Something that you got to keep an eye on. Sun kinks. Maintaining a welded rail. The importance of. One of the things on welded rail. You can only send the tie gang through there. You never could take more than 2 ties out at a time and next to each other. You had certain restrictions. We had a foreman one time where you kind of pushing to put ties. When you get into when you're doing welded rail, you can't really put in a lot of ties because you remove the ties and if it gets hot enough, you'll get these sun kinks like this. Some other maintenance type things. Track undercutter. You either a cutting blade on a backhoe. This is a ballast regulator. Plows the ballast and shapes it to get that nice ballast section that we draw on our drawings. Try this one. This is a quick one if we. This is an air dump. And what couple of things that's used for is that to dump ballast in adjacent on adjacent tracks. A lot of times it's used to dump riprap. There's air cylinders on the side that you could actually a lot of these cars can dump either way. You just got to be real careful, make sure you know what you're doing, so you dump it in their way. But a lot of times they will do that to dump riprap. What I've seen in several cases, they use those to for track construction and put dirt from something from some type of excavation. You have on track weed spray, weed spray, brush cutting, try this one again. This is a little quick video on it. This is one way to get the access to track that usually used to fix drainage situation. Here you got a blocked ditch, doing some re-ditching. It allows you to get out there. Most of the time the railroads are going to be trying to do that from somewhere, from outside. They're going to try to get contractors to do that. And the reason being is because they can get that work done. So there are some places that it is, very difficult to get to, and they're going to want to, you have to use on-track equipment like this. But when you have on-track equipment, both these two tracks, because of where he can reach, both tracks are out of service, and usually not, not something that's acceptable in the situation. But they're very efficient. There's a case where, you'd probably get somebody, but, from a contractor, you're right at a crossing, but it's able to get a lot of the work done that you're wanting to get done. Derailments, bridge tires. Just again on the situation, derailments. That's the important thing about washouts. Why you take time to. It's like another time why it's important to make sure your embankment is good. I think next week we're going to talk about more maintenance and construction, and what I'll do is we got a little late start this week, but I'll continue. This is mostly on the inspection. Next week we'll take a little bit more on some kind of program maintenance and some of the construction thing. Take a look at some of the type of construction activities that we're going to be needing, and again trying to get that understanding, the better comfort factor with the railroad itself, and just the that railroad environment, and I feel that some of it may not be a direct correlation into the design things that we do, but I think it's something that the more we understand the environment that we're working in, the better decisions that we can make in the designs that we come up with. So, not to run over too long. I'll quit right here, and we'll continue on with a little bit more of maintenance and construction next week. So, thank you for your time. And if you have any questions, or does anybody have any questions, I certainly have time to answer any questions. Okay. If not, same time next week. Again, if anybody does have any questions, don't hesitate to give me a call. So, thanks for your time.
Dave.
Steve.